Yes, beta. Good evening, everyone. I hope all of you are doing well. So once again, welcome to the Sri Chaitanya YouTube classes. Okay. Yesterday we started the topic stoichiometric calculations. Fine. Today we will continue the same topic. If it will be finished, we'll see we can start then concentration terms. So yesterday we did the very basic questions, then we did the limiting reagent, right? So we'll continue. Yes, beta, good evening. So we'll continue that topic. So yesterday we did the question mole questions and weight questions. So we will do some volume questions and then mixed type of question we will see. Okay. Then percentage yield and you can say percentage purity also will cover. Okay, bacha, let us start then. Okay, wait. This type of more slides. Yes, add this. Okay. Okay then, let us start better. So we are covering the volume question, okay? Yesterday I gave, I think one question I gave already. Let's see some more questions. Imagine we are having this reaction in which we are oxidizing SO2 to SO3. If you balance it, you can see simply. And as I said, there are some fixed equations they give all the time. So don't worry, something new reaction will come. It will come from your NCERT only, nothing else. Okay. This is the question. Imagine at the time 0, they are giving us that we are having 100 ml. We are having 100 ml of SO2 gas. Time 0 means, you know, initial time when we are starting the reaction. It is 100 ml. And imagine I am giving it as 60 ml. I am giving it 60 ml. It is 0. So your task is very clear. First of all, find which one is the limiting reactant and then find the product volume, you can say, because I gave volume. So I'm asking you the volume of the SO3 finally and the remaining volume also. So at the time finally when reaction will stop, what will be volume here and volume here. As I explained yesterday, in case of volume questions, there is no need to convert volume into moles. You can directly find which one is the limiting reactant, right? Okay, bacha, tell me fast. Yes, everyone. Yes, beta. Apply the shortcut here. Apply shortcut here. How we find which one is the limiting reactant, right? Okay, good. Second, give me right answer. How we will find beta? Given volume divided by the stoichiometric coefficient, how much? 2. And here, given volume divided by the stoichiometric coefficient, how much? 1. So which one is coming small? Yes, Lakshmi beta, right answer. So this one is the limiting reactant. This one is least number, small number. This is telling us that, this is telling us very clearly that it is our limiting reactant. So first of all, write L here. It's our limiting reactant. Okay. Now we know the limiting reactant will finish to 0. It is a reactant which will finish first and limit the amount of product formation, right? So it become 100 to what? 100 to 0. It will finish. Now I know very well. Then when its 2 will finish, is how much will finish? 1. Its 2 will finish its 1. So it's 100 when it is finishing. So how much will finish out of this? 50. 2 will finish 1. So 100 of this is finishing here. Will finish how much? 50. So how much will remain extra here? It's a 10 ml volume will remain extra. It's 10 ml volume will remain extra. And now the product beta, 2 makes 2. 2 ml makes 2 ml, or I can say 2 mole make 2 mole. So 100 ml will make here how much? 100 ml, right? Got the point, everyone? This way, if question is volume, 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 so you can easily solve this without converting into moles. Clear, bacha? I hope you are clear now. Okay? Okay, fine, bacha. One more question I am giving same way. Look at this. Okay. Here I am burning. Okay, we can burn something else. Like I am saying, we are having C2H6. You are burning ethane. You will balance yourself. C2H6 burning with O2 and giving what? CO2H2. CO2H2O. Fine? Okay, bacha. So at the time 0, at initial time, I am saying I am having its, you can say, we are having its 100 ml. I am having its 100 ml and I am having its also 100 ml. I am taking both as 100 ml. Okay? And now our question is, these are initially 0, 0. Imagine this is also vapors. Water vapors I am saying here, right? It is a gas already. So finally, my question is, tell me out of these which is limiting reactant, and tell me finally volume of the CO2 gas and H2O. Right? I'm saying water vapor, so you can take it as gas and can find the volume. Normally water is formed in liquid state here. Normally, but I'm mentioning it's okay. Tell me, bacha, fast, which one is the limiting reactant? Here I have given you unbalanced equation. So first of all, your task is to balance it. Right? So first balance it. After balancing, tell me which one is the limiting reactant, and using the limiting reactant find the product. Yes, bacha. Fast. Lakshmi is saying O2 is limiting. Yamini, O2 is limiting. Shagin saying O2 is limiting. Right? The same reaction we have done already. So if you balance this reaction, beta, what is coming here? Here 2 carbon, I will take 2 carbon here. Fine. 6 here, so I am taking how many? 3. Okay. How many oxygen here? Oxygen how many? You can say beta 2 to 4 and 3 7. So 7 is there. I will write here 7. Okay. Right? 7 by 2. Because only 7 oxygen. Here the O2 is present, so I will take here 7 by 2. So now we will check which one is the limiting reactant again by a simple method. Which one is the limiting reactant? How? 100 ml divided by quotient how much? 1. And here coming 100 divided by 7 by 2. Definitely 7 by 2 means 3.5. It is giving you small number. It is least. This one is least. So now definitely O2 will decide the amount of product formed, right? It is our limiting reactant. Fine. 7 by 2 you can say beta. 7 by 2 ml will give you how much ml? 2 ml. 7 by 2 ml of O2 will give how much ml of CO2 gas? 2 ml. Same way you go. It will become 0. Unitary method. 7 by 2 give me 2. So 1 give me how much? 2 divided by 7 by 2. So 100 give us how much? Into 100. Just I am saying unitary method. I am saying once again, 7 by 2 give me 2 ml. 1 give me how much? 2 by 7 by 2. 100 give me how much? Into 100. Right? The next case, if you go for the water, you can say 7 by 2 give me how much? 3. Right? So 1 will give how much? 3 divided by 7 by 2. And 100 give you how much? Into 100. Okay? Clear, bacha? Normally water they write in liquid state, so depends actually what they are giving in the question. If they give liquid state, then I can't apply this direct one, because I can apply this only gases. Right? Okay, bacha. Fine. I hope you are clear about it. Similarly, you can find here, if 7 by 2 finish how much? 1. If 7 by 2 finish 1 of this ml, so 100 beta will finish how much? If I want to write here, you see, 7 by 2 finish 1, so 1 will finish how much? 1 divided by 7 by 2 into 100. So how much will left here? Out of 100 beta, if I write it, it will come 200 by 7. So this much will be remaining. Okay. Definitely they will ask you product only. Definitely they will ask you product. So they can ask you any one of these. They will not make question very much lengthy. But for the concept, we are writing all the things. How much product will form and how much reactant will left, right? Up to now we have seen mole questions or weight questions or volume. Now we can see, okay, good bache. Now we will see the next part in which all terms are coming together. If volume is given, weight is given, so first of all it is easy to make all them mole. Convert into mole, then check who is the limiting reactant and then proceed. So I am moving to those questions. Okay, one or two questions we will take here. The next one. Okay, bacha. Yes, Shakin is giving right answer only. Fine. Calculations you can save it. Now the next thing is, I am taking here again the simple equation. It's N2 here and here is 3H2. It's 2 of ammonia. Fine. Clear, bache? Now what I am giving here, imagine at the time 0, initially when I am starting the reaction, imagine beta, they gave me here 2.8 gram. They gave 2.8 gram of N2 here. And here they are giving us, imagine, it's a 4.48 liter of H2 gas. It is 0. And finally what they are asking us, I'm writing here, little space I am leaving so that we can find more than we can use this space. So finally they are asking, imagine they are asking how many mole left. I'm asking finally how many mole left here, how many mole left here, and I'm asking here how many mole of ammonia will form. They have given a mixed type of question. They give volume also, they give weight also, and finally they are asking moles. So first of all, convert the given volume or given weight into moles. Then check which one is the limiting reactant and then proceed simply, right? So please tell me better, what's coming? Yes, better, right. We'll see some more reactions. Fast. Yes, bacha. So if you check here, they gave 2.8 gram of N2. Can you tell how many moles are there? How many moles are there, beta? If you want to find the mole, I'm taking here 2.8 gram divided by how much? N2 weight 28. So I can say 0.1 moles, right? I'm using this space, beta. So here I can say we are having 0.1 mole. This is 0.1 mole, right? And here 4.48 liter of H2 gas divided by how much? You can say 22.4. So how many moles are coming? 0.2 moles, right? So here coming 0.2 moles. Now it is very easy to check which one is the limiting reactant. Fast. Okay, Shakin is saying S2 is limiting reactant. Neeraj is saying S2 is limiting reactant. Niranjan, sorry. Right? So how do we check? Again, same thing. That method is common. We are doing in every reaction. Who is the limiting reactant? How we decide? Given moles 0.1 divided by stoichiometric coefficient 1. 0.1 by 1. 0.2 divided by how much? 3. Right? This is coming small number, right? This is coming least. Almost you can say 0.066. Least is coming, right? That's why I will say this is our limiting reactant. I am taking this one as a limiting reactant, right? This is our limiting. So limiting the finally become what? 0. Limiting will finish to 0, right? And limiting will decide the amount of product formed, right? So I am taking here, you can see 3 makes 2. Sorry, you can say 3 mole make 2. So 1 make how much, beta? 1 make 2 by 3, right? And then 0.2 will make how much? Into 0.2. Unitary method. 3 makes 2. 1 makes how much? 2 by 3. 0.2 make how much? Into 0.2. What is coming from here? It's giving us 0.4 by 3. It's giving us 0.4 by 3. Fine? Okay. Now if you want to find how much will left, you can say same thing. 3 consume 1. If 3 consume 1, beta, 3 consume 1. So 0.2 consume how much? You can say 0.2 consume 0.2 by 3, unitary method. So how much we left here? 0.1 minus of 0.2 by 3, because it is consumed. It is consumed. Okay? Yes? Are we clear here? Fine. Yes, bacha? Okay? Good, good. Right. Oh, great, you are doing great. So next question I am taking here. This time I am not giving the reaction. Okay? So I am giving here, look at this. I am saying 5 moles of lead nitrate. 5 moles of lead nitrate on heating. 5 moles of lead nitrate on heating will produce how many moles? I will say how many moles of, let me ask you some different thing. I'm asking how much weight of NO2 gas and how much volume of O2 gas? Right? Now definitely we need reaction here. Can you think about it? Now we need reaction here, right? Can think about it. This is lead nitrate. Pb plus 2 is there. Pb NO3 twice is making here PbO NO2 plus O2, right? Can you balance it first? Can you balance this? Yes, beta. Okay, Bhavadesh, good bache. Can you balance this? Then think about the reaction. Then think about the question. First, write the equation. Equation I gave you. Now balance it and think about it. Yes, bache. Tell me fast. So if you see, if you will balance it here we need, tell me what is coming on balancing? Is it 2 coming here? Is it balanced now? How much total oxygen coming? It's Pb and twice. Now how much Pb? 1 Pb here, 1 Pb. Nitrogen how many? Nitrogen 2, right? And oxygen how many? You can see we have 6 oxygen here. How many here? 2 to 4 and 2 6 coming here. 2 coming, right? So if you want to balance it further, look at this carefully. If I take 2 here, or I can take here how many? 3 to 6 here. Here how much? 1 and 4. Can I take half here? Now is it balanced? Just we have to balance it hidden trial method. Other balancing you will see in the redox chapter. Fine. Now we can see the balancing part. 1 Pb here, 1 Pb. Nitrogen how many? There are 2 nitrogens finally. There are 2 nitrogens, you can see. There are 2 nitrogen. Oxygen how many? 3 to 6 oxygen, right? So how many here? 1 here. How many here? 2 and 2, 4 and 1. So total 6, right? Now you can see, stoichiometry you can see now. Now tell me clearly, at the time 0, how much they gave? They gave me 5 moles. Its 5 moles are given. And these are given 0, 0, 0, imagine. Right? At the time finally, first of all, you can find the mole of all things. First find the mole of all things and then convert whatever you want, like you want volume or you want weight. So please. So 5 moles are there. This 5 will finish. 5 will finish. So one of this produce 1, right? 1 produce 1. If it's 1 produce 1, then 5 will give how much? 5 of this. I am getting 5 moles. 1 give 2 here, right? One of this give 2 here. So 5 will give how much? 10 moles. 1 give how much? Half. So 5 give how much? 2.5. 5 give 2.5. Clear? This is how we get the moles of everything. We get the moles. I am writing here, these are moles, right? 5 moles. It is 10 moles. It is 2.5 moles. Now in the question they're asking something else. They're saying find the weight of NO2. We know how to convert weight into moles, right? But how we find the weight? Moles into what? Moles into molar mass. NO2 molar mass how much? O2 how much? 32. 14. So how much coming? 46. So from here into 46 I can write. Similarly, if you want to find the volume, how? We can convert moles into volume. How beta? How we can make it? I'm writing here. So moles, 2.5 moles into how much? 22.4 liter, right? So if question is coming mix, so first of all using mole, find the mole ratio and then convert it whatever you want. Okay, right? Yes, 56 liter and 460 gram. Oh, Gayatri, Lakshmi saying right only. Okay, fine. I hope we are clear now. Okay, so definitely there are more questions, more type of questions. Many questions are possible here. You will see more questions in your offline classes, right? Now I am just discussing the basic things. You should get the idea about it, right? But the most important part we discussed. Now I am coming to next type. You can say one small topic will come, in stoichiometry only, the percentage purity. Fine, bache? So we are taking the topic percentage purity. Next one. Okay, right. You gave the right answer only. Very good. Great, bache. Yes, Samini. Good, bache, right? Gayatri also gave right answer. Lakshmi also gave. Sudhakar. Okay. The next one. A small point will be added in our questions of stoichiometry, that is percentage purity. And students make mistake in this topic. Okay, easy topic, but students always make mistake here. So be careful about it. Percentage purity. What that means first of all? It is given amount of reactant. Right? Given amount of reactant divided by what? Pure or actual amount of reactant. Actual, or you can say pure amount of reactant. Okay, into 100. Okay. So what that means, let us understand. Let us understand what they are saying from here, okay? Sometime what they will do, look at this. Example I am taking. Imagine your father told you, go beta, from market, buy some CaCO3, okay? You are going to market and from the market you are buying the calcium carbonate. Okay, and you are saying to the shopkeeper, uncle, give me the calcium carbonate. Give me 100 gram of calcium carbonate. You are saying that part, right? So you bring a packet. Imagine you bring a packet of CaCO3 and on the packet it is written very clearly 100 gram CaCO3. Right? On the packet it is written that you are buying 100 gram of CaCO3. But you know today's situation, whatever you buy from the market, some impurities will come in that. Okay? Shopkeeper or every company is trying to cheat us. Clear? So from the market you are buying this written 100 gram, but it is not actually 100 gram. Some cheating is going on, right? Imagine when your father opened the packet, he found that it is containing only 80 gram CaCO3. Actually, it is containing only 80 gram CaCO3 and remaining 20 gram is impurity, sand or something else. Means shopkeeper cheated you. Out of written 100 gram of CaCO3, actually only how much? 80 gram, and 20 gram is cheating. 20 gram is cheating, right? So now you know that if from the market you are buying this CaCO3, so how much purity is there? Can you tell me? This packet is how much pure? This packet is how much pure? Tell me. If out of 100 gram, tell me that is how much? Okay. Sorry. Wait for 1 second. Here we are finding percentage purity. Just wait 1 second. Just wait for 1 second. Okay, here we are finding the percentage purity. Here it is the pure. Pure or actual reactant, and here beta given amount of reactant, right? Okay, sorry for that. Upside I will write pure reactant and divided by what? Given amount, right? I wrote reverse way, sorry for that. It is a formula. Percentage purity, pure reactant divided by which one? Given reactant. Tell me beta everyone. Right? So what is coming, bacha? 80 gram is the actual one. 80 gram CaCO3 is present actually. 80 gram is the present actually, and divided by how much is the present here? 100 gram, right? 100 gram from the market you bought. 100 gram from the market we bought, but actually how much coming only? 80 gram is coming, right? 80 gram is the actual one. 100 gram we bought, into it how much coming? 100. So it is only 80% pure. It is only 80% pure, right? So because of cheating in the market, you see, only 80% is pure. So actually from the total given reactant, I have to find the pure reactant, which I will use in our stoichiometric questions. Fine? Clear? Same thing I am giving once again to very much clear here, right? Imagine this is the packet on which they are writing we are having 150 gram of glucose. Imagine they are saying 150 gram of glucose. On the packet it is given, right? Now when I open it, actually I found that it is only 125 gram glucose actually. Okay? And what is there? 25 gram is what? Impurities. They added something else. So please tell me, what is the percentage purity? Yes, beta. What is the percentage purity? Fast. In this case, how much purity is there? In 150 gram packet of glucose, only 125 gram is glucose and 25 gram is impurity. Tell me fast. In the second case, how much purity is there? Tell me, bache. Yes. How much is actually? 125 is the actual amount. 125 is the actual amount. Out of how much, beta? Given how much? 150. 125 is the actual pure amount and divided by how much? 150. Right? Okay. Into how much coming? 100. What will come from here? 25. I will take here how much? 5, and how much here? 6. Okay. So beta 25 into 5 here and 6 here. So 5 by 6. I can say 500 divided by 6. Right? Okay. 83.32 you are saying, right? Right, bacha? Okay, 6 if you take beta 6, 8, how much coming? 18, 2 coming. So 6, 18, right? 83.3 something. Good. I hope we are clear now. Okay? So almost 83. Now reverse I am asking. I am asking reverse, right? Okay? Look at this. What I am asking. The question is, in this case, I am taking here. Imagine in this case, I am saying we are having a packet is writing here, it is having 200 gram CaCO3. And they are saying it is only 75% pure. Packet is writing that they are having 200 gram of CaCO3 and they are saying it is 75% pure. Can you find actual or pure CaCO3? How much better? Find me pure CaCO3 or actual CaCO3. Tell me. This time they gave purity and they are asking me how much is pure out of this. The 200 given is not pure. It is the just written. Actually is how much in this? First, is better. Okay, very good. If you see beta here, how much? Out of 200, you see, they gave me this is 200. This is how much? 75%. 200 here, 75 here, and 100 downside, right? So out of this 200 into 75 by 100, right? What is coming from here? 25 into 3, 4. 4 coming how much beta? 50. So how much coming? 150 gram. So 150 gram is the pure one, okay? This way you will find the pure reactant and then I will use stoichiometry. So be careful about it, right? By chance, if you have the pure reactant, you can find which one? Given also. You can find given also. I am asking you a reverse question, so be careful about it. Be clear about the formula, okay? Fine. Now, how much 50%, how much 50% pure CaCO3 will be required to get 200 gram pure CaCO3. Be careful what I am asking. From market, I should buy how much CaCO3? From market, it is only how much pure? 50%. So that when I open the packet, the final CaCO3 must be how much? 200 gram. The pure amount is how much? The pure amount is 200 gram, right? So from market, I should buy how much? From market, I should buy how much? Tell me. It's better tell me fast. If you give me this answer, then you are clear about it. Yes, Shakin, very good answer. 400. Niranjan, 400. Yes, very good. Now you know this topic. Very good, right? How much is purity? 50%. Pure reactant, I need how much? 200. I need given reactant or given substance into 100, right? So how much I should buy from market, right? So given reactant or the reactant I should buy from market will be how much beta? 50 here. Given go upside. So 200 divided by 50 into 100, right? How much coming? 400. Very good. So from market I will buy 400. When I will open the packet of 400 gram of CaCO3, actually how much will come? 200. So be clear about the formula, okay? Students make mistake here. They do reverse thing. Some students gave answer 50 gram here. Sorry, 100 gram. Reverse it. No. So please be careful about, right? Okay, but now come to the questions. How we will use it in our question, okay? Write this one. First one here. Find volume of CO2 that can be produced. Find volume of CO2 that can be produced by heating 200 gram of 80% pure CaCO3. Be careful. The question is very simple, but the thing is changed when they're saying 200 gram of 80% pure CaCO3. Fine. We know the reaction, right? If you are not clear about reaction, I am writing CaCO3. Give us what? CO2. Before applying the stoichiometry, first of all, find the pure amount of CaCO3. Impure amount will not give us the product. Pure amount of reactant I need to apply the stoichiometric concept here, right? They're writing here 200 gram, but this CaCO3 is not pure. Out of this, only how much is pure? Only 80% is pure. Out of this, only 80% is pure, beta. So first of all, find the actual CaCO3 or pure CaCO3, right? By the previous concept I told just now, right? First of all, find the pure amount of CaCO3. Okay, I'm writing here a little bit, you see. Before starting the stoichiometry, find pure CaCO3. They gave us 200 gram. It is only 80% pure. So actually how much CaCO3 present? 160 gram. So actually here 160 gram is the pure one. It's very good. So 160 is the pure. Now apply the concept here. Okay. So 160 gram beta means how many mole? You can tell me how many moles are there? 160 divided by the molar mass 100. Becoming how many moles? 1.6 moles. Now we can apply simple stoichiometry. We know that at initial time 0, at time 0, we have taken 1.6 mole. It's 0 mole. As time will pass, these mole will finish. It's 1 mole give 1 mole, 1 mole. So 1.6 mole give how much? 1.6 mole. Give 1.6 mole. Right? Okay. So 1.6 mole beta. 1.6 mole though we got. But in the question they're asking volume. You know volume? Number of mole divided by 22.4. How much coming from here? Okay. Okay, many of you writing 35.4. That's great. Good. I'm writing 35.4 liter. Is it clear there? Are we clear about this? Okay, good. Fine. Now I am giving one more question this type, okay? Done? So from the given reactant, first of all, find the pure reactant. And using the pure reactant, then find the product. Because the product can be formed only from the pure reactant, okay? Impurities you can't make product. So from the given reactant, find the pure reactant. From pure reactant, find the what? Products, right? Okay. Let us see the next question. For your help, I am writing the equation. Well, maybe equation will be new for you. It's MnO2, 4 of HCl is giving MnCl2 plus Cl2 plus water. This is the question, right? Yes, but I am good. So MnO2, this is the reaction. If you balance it, is it balanced or not? No. Is it balanced now? Yes, it is balanced now, right? Okay, this is the balanced equation. So in the question, what they are giving? The most common question of this topic. Always they ask. The most common question of this topic. In this question, I will ask reverse way. I will give you product amount. From that, you will find the pure reactant, and then you get the percentage purity. Okay? So carefully look at the question. I am writing here. If 10 gram given amount of MnO2 can produce only 2.24 liter of Cl2 gas, then find the most common question in this topic. Then find percentage purity, the percentage purity of given MnO2, right? For your help, just for the molar mass of MnO2 beta, Mn is 55, O2 means 32. The given mass how much? You can find 87 gram per mole is the molar mass of MnO2. This question is reverse. In this question, they are saying this 10 gram of MnO2. This is not the pure amount. This 10 gram MnO2 is not pure. In this 10 gram, some is the actual MnO2, some is the impurities. But whatever amount of MnO2 is present in this 10 gram, it will be able to produce 2.24 liter of which gas? Cl2 gas. And Cl2 gas can be produced only by the pure amount of what? MnO2. So reverse way we have to go. Can you think about it? It is the most common question you can find in every book, everywhere you will find it. Whenever this topic comes, this is the most common question, okay? Let us understand, right? Carefully. Okay, so be clear about stoichiometry. 1 mole MnO2 need 4 mole HCl. Give 1 MnCl2, 1 of Cl2 and 2 of water, right? This we can see by the stoichiometry very easily. Fine. So let's understand now. First of all, tell me how much Cl2 gas is produced. How much Cl2 gas produced? Cl2 gas, tell me how much? 2.24 liter of Cl2 gas, right? How many moles are there? Tell me. If I want to find how many moles of Cl2 gas are present here, it is 2.24 liter divided by how much? 22.4. So I can say indirectly that we are having 0.1 mole of Cl2 gas produced. So actually 0.1 mole of Cl2 gas is produced, right? Now check carefully. Understand this very carefully. 2.24 liter of Cl2 gas means actually how many moles produced? 0.1 mole, right? 2.24 liter Cl2 gas means 0.1 mole of Cl2 gas produced. And now we can see here, its 1 mole can be produced by its 1 mole, na? So its 0.1 mole is produced by its also how many mole? 0.1 mole, right? 0.1 mole of MnO2 means how much weight? 0.1 into molar mass, but I know how much? 87. So I can say 8.3 7 gram. So basically 2.24 liter of Cl2 gas so can be produced by only its 8.7 gram. Means out of 10 gram of MnO2, 8.7 is the pure one and 1.3 is the impure one. Are you getting my point? The product will be formed always from pure reactant, right? The product will be formed only from what? Pure reactant. So from the product I found the what? I found the what? Pure reactant, right? Now I can say that what is the percentage purity of our given reactant? 8.7 is the pure reactant actually. Divided by 87. So how much coming? Sorry, divided by 10. Na? 8.7 is the pure one out of 10 gram into 100. So how much coming? 87%. Okay, sometimes they ask you reverse, they ask you different thing, they ask percentage impurity. So please tell me what is the percentage impurity here? Tell me. What is the percentage impurity? Purity is 87%. So how much will be impurity? 13%. 100 minus purity, na? It is just 13%. I hope we are clear here. It's a good question, right? Cl2, the product, will tell me how much reactant is actually used. This reactant is the actual amount of MnO2 present. Actual amount divided by the given amount. We can get the purity and impurity as well. Very good. Okay, everyone? Yes? Okay, fine. Let us see one more question. Okay? Then we will come to the percentage purity. Okay, bacha? Fine. I hope everyone is done here. We're done up to here? Okay. Find weight of 50% pure. Find weight of 50% pure CaCO3 required to completely react with 2 moles of sulfuric acid in given reaction. Right? Definitely confusion can come in the reaction, so I'm writing reaction. CaCO3 is reacting with sulfuric acid is giving you CaSO4 plus CO2 plus H2, right? This is the question. Is it balanced? Beta is balanced. Ca here, sulfate is here. Right? Right. Is it balanced already? This is balanced. Fine. Okay. Now you see. Now you do by yourself. First of all, simply apply stoichiometry and tell me how much CaCO3 is required to react with 2 mole of what? Sulfuric acid. Then find the actual weight, what is required, and then look at the percentage purity topic. Okay? So what they are saying it here, look carefully. Stoichiometry very much clear. 1 mole need 1 mole makes 1 mole, 1 mole, 1 mole, right? They are giving, I am having 2 mole of sulfuric acid. They are saying I am having 2 mole sulfuric acid. So please tell me, if with its 1 mole I need its 1 mole, with its 2 mole I will need how many mole? Tell me, I will need how many mole of CaCO3? I will need how many moles of CaCO3? Tell me, using stoichiometry simply. 1 mole need 1 mole, 2 mole need 2 mole, that's it. Very easy. 1 mole need 1 mole. So 2 will need how many? 2. Stoichiometry simply. Now 2 mole are given. Can you tell me how much weight, beta? 2 mole of CaCO3 means very easy to find. I can say how much weight I need. 2 into 100. So actually though, I need 200 gram of CaCO3. Yes. Actually though, I need 200 gram of CaCO3, right? But now look at the question carefully. In the question, they are saying the CaCO3 which you are buying from market is only pure how much? 50%. So from market, how much you should buy? Yes, Gayatri gave right answer. Gayatri, very good beta, very good. Yes, Mandeep, right answer. Now we know very much. We know that the percentage purity is how much only? 50% pure. Okay? The pure amount I know how much? 200 gram. We need given reactant. So how much we have to buy? Into 100. In the formula of percentage purity, pure I have, given I need, 50 is the percentage into 100, right beta? So what is the given or the CaCO3 I should buy from market? That is coming 400 gram, right? Yes. Chetan did little mistake. He is saying 100 gram. Otherwise, remaining all give right answer. Don't make mistake. 200 gram is the actual I need. From market, I will buy how much? 400 gram. Out of 400 gram, 200 is the actual pure. Remaining 200 is impurities, right? Chetan, you got the mistake? What mistake you are doing? In this formula, I have the pure one. I have to find impure. Okay? Pure, impure I need to find. Impure how much is coming? 400. I hope we are clear now. Reaction will always give us the pure reactant. Stoichiometry reaction will give us always the pure reactant. Okay? Shakini beta, offline class will start in first week of this month, right? The next month is coming, right? June first week it will start. Okay, Chetan beta, okay, Chetan. Now you're clear? Chetan, are you clear now? Okay, good. I'm saying once again, percentage purity, you can write this way also. It is a pure reactant here. Divided by the given, you can say given, or you can say impure. Because from market we will buy it and we will get impure into 100, right? Now question, the reaction give us how much? Reaction is telling I need 200. It is 50%, you have to find this one. It will come 400, okay? Fine, beta, good. This is your topic of percentage purity. Okay. Now a small topic is there, that is your percentage yield. Okay. So what is that? We'll understand the part. Okay. The percentage yield. What that means. Small topic. Okay. What is that? Actual amount of product formed. It is the actual amount of product formed divided by the expected amount. Expected amount of product into 100. Right? This is the percentage yield. Actual amount of product actually formed divided by the expected amount. Okay. So how this will be involved in our questions, we will see. Imagine you asked, father, give me 1,000 rupees. You were expecting your father will give you 1,000 rupees to pay. Okay. You were expecting your father will give you 1,000 rupees, but actually yes, Abhishek beta, in the first week offline classes will start, right? In first week offline classes will start. Okay. Or you can contact the given numbers, right? In first week, most probably classes will start. So first of all, let us understand what is the percentage yield once again. Imagine you were expecting your father will give you today 1,000 rupees. So your expectation was 1,000 rupees, but when you received only 200 rupees. So you received actually how much? 200 rupees. But you were expecting how much? 1,000 rupees, right? So that way you have to think. I will tell you what is the meaning of all this topic. You will understand that part. Look at this. Actually, I received only 200 rupees, but I was expecting how much? 1,000 rupees. So how much is the actual percentage yield beta? Only how much? 20%. The actual yield is only 20%. How we will use this in our question, you will understand. Okay, bacha? Fine? Let us understand this whole thing. How question will come? Look at this. Question is, imagine I am taking the simplest equation once, then we will take the different equations. Here we have CaCO3 is giving us CaO plus CO2. Fine. Now what is it? I am writing here initially I am writing here I am having its 5 moles. I am having its 5 moles, right? The time is 0, time is 0. Can you give me the final answer? How many moles of this will be left in the end? Or just I am asking a simple thing. Tell me here, here, here. Apply simple stoichiometry and tell me when this will finish, how many moles of both will form? How many moles of CO2 and CO will form? If I don't give you anything, if I don't give you any yield, simply I'm just asking this one. Yes, beta, you have chances, beta. This time cutoff will be very less. Right? So let us see. Cutoff will go up to where? But definitely it will be less than, like, from last year. It should be less, like 100 marks less, or 80, 90% less. In this question, I am asking a simple question. I am saying here 5 moles, here 0 moles, right? So this will finish, but this will finish, and it will come how much? 5 and 5. How I am saying? Because 1 mole of this give me 1 of this, 1 of this. So 5 will finish, give me 5, 5, right? Yes, Devik. Total 10 moles, 5, 5 moles, right? But imagine the same question. Imagine if same question comes, but some different thing is given. Imagine in the same question, they are saying, I am writing here above side 80% yield. In the same question, if I change little data, I added that the above reaction is giving only 80% yield. Up to here in our question, our answer was very much clear that I was getting how many mole of CO? 5 mole of CO, and I am getting how many mole of CO2? 5 mole CO2. But now the thing is changed. Now you look at the formula, it's very much clear. From the reaction, we were expecting that I will get 5 mole of CO2. But the yield is only how much? 80%. So how much is the actual one? Look at this. 80% is a yield. Right? Actual mole of CO2 I want to find. Expected how much? What is the expected beta? Expected how much? 5 moles. Expectation was 5. Okay? Here 5 into how much? 100. So if you solve from here, the actual mole of CO2 is coming only how many? 4 moles coming, right? So if this yield comes, if this yield topic comes, then you have to apply this part only. Whatever is coming by stoichiometry, put it here, expected, and then find the actual. Because of some situation, reaction was not able to go to complete. It will stop somewhere in between. If reaction will stop somewhere in between, then I will get the less amount actually. So apply this simple formula to get the answer. Okay. So these are the moles actually formed. These are the CO2 moles actually formed. Are we clear about it? Yes, beta, Saeed, beta. I hope you did very well, and definitely it is your hard work only. Okay. Our work is just to teach you and guide you, but still I am very much happy by your result. Thank you very much. Okay. Okay, bache. So now look at this part. I'm saying once again, first of all, using stoichiometry, find the final product. If they are writing the yield is 80%, 70%, then apply the formula and find the actual amount. I'm saying once again, understand carefully. Imagine you were expecting that in 1 hour I will do 50 questions. In 1 hour I will do 50 questions, right? You were expecting that. But suddenly in between the process, light or electricity gone, now you can't read. So 50 were expected, but actually you did only how many questions? 40 questions. So because of some situation, reaction will not complete. Reaction will stop in between somewhere because of any reason, and we get some less yield than our expectation. Right, bacha? Good. Now, I'm taking one more question. Understand this, okay? A very simple question. N2 here, S2 here. The most common question of this type, right? This is the question. At time 0, beta, I am writing here, it is 30 liter, it is 30 liter, it is 0. So the question is, if they write here, this reaction is giving us only 50% yield. So our question is, you have to give me answer, volume of ammonia formed actually. Okay, this is the question. Using stoichiometry, first of all, simply find how much volume should be formed, expected. Then apply the topic of percentage yield to get the actual volume of ammonia formed. Please. Make it fast. Okay. Is it a fast? Give me answer. Yes, Gayatri gave the right answer. Gayatri is saying 10 liter. Right answer, beta. Good. First of all, apply simple stoichiometry, which we did already. Don't think about the yield topic. Just think like this one. Simply, first of all, our target is to find which is limiting reactant. 30 by 1 and 30 by how much? 3. It is small number, least number. It is telling us that who is the limiting reactant. It is the limiting reactant, right? Now I know which one is the limiting reactant, right? Who is limiting? S2 is limiting. Limiting will become 0. Limiting will become 0. So now 3 give me 2. 1 give me how much? 2 by 3. 30 give me how much? 2 by 3 into 30 beta. How much coming? 20 liter. So our expectation is I will get 20 liter of ammonia. Our expectation is I will get 20 liter of ammonia, right? But our expectation will not be full, will not be fulfilled, right? Because it is only how much yield? 50%. Okay? What we will do? We apply a simple formula, beta. We apply a simple formula. Yield how much? 50% yield. Volume of ammonia I want to find actually. Expected how much? 20 liter into 100. What's coming from here? Volume of ammonia actually formed will come how much? 10 liter. 20 was our expectation, but we will receive only 50% of that is 10 liter. Okay? Yes, so our answer is coming 10 liter of ammonia will be formed. I hope we are clear now. Okay, same last question on this, beta. One more last question here. Give me answer carefully. How much volume of CO2 gas will be formed by 5 moles of CaCO3 by 5 moles of CaCO3 if reaction yield is only how much? Only 60%. Reaction yield is only 60%, okay? Carefully give the answer. Reaction we know the most common one. CaCO3 give you what? CaO plus CO2, right? Initially they gave me 5 moles, 0, 0, right? Finally we expected what? It will finish to 0. How many moles? 5 moles and 5 moles, fine. So we were expecting that we will get 5 moles of CO2 gas, right? We were expecting by the stoichiometry, but because of some situation, reaction will stop in between and we will get less, right? Okay, I can solve it here. So we were expecting that we will get about how many? 5 moles. So if I say volume of CO2 actually with how much we'll get? Actual. We were expecting that we will get 5 into 22.4 liter, but we will receive only this 60%, right? So how much? 60 divided by 100. How much coming, beta? Yes, beta. Tell me what is coming. What is coming finally? 60% of expected. This is expected one. This was expected one, na? 5 into 22.4. So what is coming actually? Only it's a 60%. How much coming? Fast. Okay. Shakin is saying 67.2 liter. Okay. Yes. Yamini is saying 67.2. Fine, bacha. Good. Great. I hope we are clear about this topic. So today we focused on limiting reactant, percentage yield, and percentage purity. Okay. Tomorrow we'll do some questions from the PDF for this topic, and then we will start our next topic, that is the concentration terms. Okay. Tomorrow topic is very important. So see you soon. See you tomorrow, beta. Bye then. See you. Bye. Thank you very much.